When you're creating a service using AWS and Serverless, you need to be able to test the changes that you're making as you make them. There are basically three main ways of doing that, which are either using a test-driven design process, testing the APIs manually, using something such as Postman, or actually connecting up to a local version of your application and seeing if the application and your backend service work together. With all three of these processes, we need to decide whether the backend is going to be running locally or it's going to be running in AWS. Today we're going to be discussing the advantages and disadvantages of both running locally and deploying your service to AWS, and in which scenarios you would use either one. Make sure you stick around to the end of the video, as that's where I'm going to be giving my opinion on when I would use each of these services. Also, I want to say that Complete Coding is hiring, and if you're interested in working with me as a serverless engineer, then there'll be some more details at the end of the video, as well as in the description below. Hi guys, my name is Sam with Complete Coding, where our aim is to make you into the best AWS and serverless engineers that you can be. In this video, we'll be looking at the differences between running and testing your serverless service offline or deploying it to AWS for testing. In this video, when we're talking about testing, we're talking about when you have a VTL template or some Lambda that you are writing and you want to test the line of code you've just written, or added a console log or something else, and you want to see that that bit of code you've just added is functioning as expected. We're not talking about testing a finished feature, as when you're doing that level of testing, it should always be done in AWS. So the two types of scenario that we're going to be looking at are running things offline or in AWS. When we say running things offline, we mean using something like the Serverless offline plugin and then using other extension plugins such as DynamoDB Local to run a local version of Dynamo so that you can have your APIs and your Dynamo tables running locally and test the full scope of the functionality that you have created. If you're using other services such as S3 or step functions, then there are other plugins for serverless which allow you to run those locally as well. So what are the advantages to using serverless offline? Well, the first one, and probably the most important, is that it is super fast. If you use Webpack and hot reloading inside serverless, then you can sometimes make a change to a Lambda, save that, and within a fraction of a second, that is already updated, and you can retest that same API. If you're using something like Postman to manually test it, that involves one button click and you get the response back straight away, as well as all of the logs inside your terminal. This allows you to really quickly iterate and make small changes, checking them as you go. The next advantage is that I've just said that you get the logs in the terminal. This is really nice, as you don't have to go into another view or into your browser to be able to get the logs and see exactly what is happening throughout the process in your Lambda. Next is that with something like DynamoDB Local, you can actually seed your database with a specific set of data whenever you start up your serverless offline. This is great because it means that every time you start running locally, you know that you're going to be in exactly the same state. And this just makes testing things a lot easier. For example, you could have one user that you always set to be in an error state, which means testing functionality around error handling is much easier. The fourth advantage to serverless offline is that there is full isolation. If you're developing this application within a team and you're making changes to an API and running it locally, you are the only person who is going to be affected by those changes. That means if you've got 2 or 3 developers working on the same set of APIs, you aren't going to have one of them making a change which affects the ability for the other person to do their work. This is really nice, as those conflicts can often become really frustrating if you've got to wait for someone else to finish their work before you can continue yours. The final advantage that I see for serverless offline is, well, that you can do it offline. Because everything does run locally, you don't actually need an internet connection to be able to test your service and any changes you've made. Whilst this may not be a massive advantage in the modern world with internet everywhere, there have been a couple of scenarios where I've been travelling, so either on a train or on a plane, where I haven't been able to get consistent internet access, but have been able to build out some new features for a client, or just add some extra functionality to a project I was working on. So those are the advantages, but now let's move on to the disadvantages of serverless offline. The biggest disadvantage to going with serverless offline is that you aren't actually running the real AWS services. You are running some sort of mock of that service. So with something like API Gateway or DynamoDB, these are incredibly good mocks which are almost identical, and in the case of Dynamo, you are actually running the Dynamo database in a local environment, in which case that is absolutely fine and it will produce as good results in deployment as you found locally. Unfortunately, there are some services which don't have as strong mocks, or no mocks at all. If your service includes any of the services like Cognito, or Athena, or Amazon Lex, then trying to find a mock is going to be a lot harder, and for some of the services, you probably won't be able to find a mock that is exactly the same as the AWS service that it will eventually be running on. Of course, there are other services such as Step Functions or EventBridge where there are mocks available, but to get those mocks running properly, you need to add extra config to your serverless project, or add even new APIs to, for example, trigger events going into EventBridge. None of this is really ideal, and you can't reliably say that if it runs offline, it is absolutely certainly going to run identically online. The next disadvantage to running offline is that your local machine can affect how your systems run. For example, do you have some global NPM packages installed, which are going to get used by your Lambda? If they haven't been deployed as part of that Lambda package, then your environment is different to the one it's finally going to be running on. You also need to check things like, is your Node.js version or Python version exactly the same on your local machine as the one you're going to be running inside AWS? This can result in the situation where it runs locally but doesn't work when you're deployed, which is always a frustrating situation. The last major disadvantage to using serverless offline is when you're developing a larger architecture which comprises of multiple different microservices. The challenge here is that if you are testing one of your microservices and you need to test it with its compatibility with all of the other microservices in your offering, you need a way of communicating your local offline microservice with your online and deployed other microservices. This can be complicated because when it's running locally, it isn't accessible to the internet. Obviously, you could use something like ngrok to expose an API to the internet, but then you also need to bake into every single one of your services a way of telling it that service X is running locally and to contact it that way. This can be done, but it does definitely increase the complexity of all of your services. So now let's talk about deploying directly to AWS. This is exactly as it sounds, where anytime you make a change to your serverless project and you want to test it out, then you need to deploy it to AWS. You then test it by either triggering the real events, hitting the API endpoints that you have just made, and seeing the response. So the advantages for this are that you're using the real services. This means that it should function exactly the same in development as it does in testing, as it does in production, because the environment that it's running on, AWS, is identical. This removes that whole challenge of it runs on my machine but it doesn't run in production, which is a really nice thing not to have to worry about. The next advantage is that you can test any AWS service. You don't need to find a mock or create a mock for anything, as you're using the real services. This means you can have probably a more complicated architecture with different services calling each other, and you know that they are going to work. If you know that you are using a more obscure service, such as Amazon Lex, then testing it in AWS, you know that it is going to function as expected. The next advantage is that with the serverless framework, you can actually just deploy a single function code instead of having to deploy the whole stack. This would have been a massive drawback if every time you wanted to test anything you had to deploy the whole system again, but instead you can just update the code, which may take between 2 and 5 seconds, and then you can test it again. The last advantage to deploying your service to AWS is that you can stream your logs from CloudWatch directly to your terminal. This obviously reduces the effort for testing out any changes you've made and speeds up the cycle from change to discovery and to the next change. So now that we've looked at the advantages, let's talk about some of the disadvantages to deploying your service to AWS for testing. The first disadvantage to working with a deployed version of your service is that if you're working as part of a team, then there can sometimes be conflicts as different developers are deploying their feature changes into the same location. This could be that someone changes something in a DynamoDB table, and that changes the result of what you're working on, or even if you have two developers that are wanting to change the same Lambda, they both end up overwriting each other, which is a massive frustration. These conflicts are also why it's not absolutely guaranteed that if your feature works at this point, it will work when it is deployed to a development or production branch, because there are situations where something another developer has done in their feature development is actually allowing your feature that you're working on to also work. This is a bit of an edge case, but it definitely does come up. The next disadvantage to deploying your service to AWS is that although you can do a function deployment to deploy just the code to update a Lambda, if you're making any changes to any of the other configuration inside your service, you need to do a full serverless deployment. This can sometimes involve deploying every single one of your Lambdas, packaging them up, and that can sometimes take up to maybe a minute or even longer to deploy. Whilst this isn't as much of an issue if you're just creating an API with a Dynamo backend, if you're doing things with step functions or with EventBridge, or you're making quite a lot more changes in the resources section of your serverless project, then each of these minute of delays can add up and become a bit frustrating to work with. The final disadvantage to deploying your service to AWS is that although you can stream the logs from your Lambdas and from CloudWatch, there's definitely a bit of a delay between when you run that Lambda and when the logs are streamed to your machine. So I did some testing with this, and it took somewhere between 8 and 15 seconds between the Lambda completing and me getting the API response and the logs turning up in the console. This obviously isn't perfect because that extends the time it takes to do that cycle of testing, finding out the results, then being able to make a new change and retest that new change, which obviously slows down development. So as I promised at the start of this video, I'm now going to tell you which process I prefer to use. Unfortunately, the answer isn't as straightforward as always use this or always use that. It depends on the project, what kind of services are involved inside our project, as well as am I working on a team, what are the deadlines, and how do I want to work on this part of that feature. So my general rules of thumb that I do have though is that if the project or the work that I'm currently doing is largely based around Lambda, API Gateway, and DynamoDB, then I feel very confident just using serverless offline. This means that I can develop all of my APIs and know that they're going to be exactly the same when I deploy them to a real AWS account as they are running offline. This also means that the time to develop those features because of the local set of logs is a lot quicker, and the kind of work that this tends to be is the incremental improvements to Lambdas where you go through adding the features that you need. On the flip side of that, if I've got a project where I'm using lots of different AWS services, or I'm using services that may either not have mocks or less developed mocks than the Dynamo ones, then yeah, I'll go with deploying this to AWS. This could be something like EventBridge with step functions, or doing some architectural design using loads of other AWS services. And in this case, yes, there is going to be that extra delay between deploying your whole service to AWS every time there's a change. But these kind of projects also tend to be the kind of projects which are more around the solution architecture and software design process. And for that, having an extra minute to contemplate what your next step is going to be, or to think about which architectural pattern you want to use for this next feature, is definitely not a bad thing at all, and is something that I quite like incorporating, because with these big architectural decisions, rushing them can often lead to issues down the road. Now, obviously, this isn't quite as cut and dry as if I'm doing APIs, I'm using offline, and if I'm not, I'm using a deployed version. During a project, I'm probably going to use bits of both. If in the architectural project, I need to create 3 or 4 APIs, I might just use serverless offline for those 2 or 3 features. And likewise, once I've created all of my API endpoints, if I'm doing something larger, such as getting rid of the Dynamo tables and creating a different structure for my Dynamo data, I might want to just deploy it and test a deployed version. If I don't want to deploy over the development version, I can just deploy to a feature deployment and test that those changes have worked. So it's not as cut and dry as this or that, but now you have a better understanding of when you might want to use different processes for testing your services. Now, as I mentioned at the start of this video, Complete Coding is looking to hire a serverless engineer to join our team. Complete Coding also has a business-to-business side of it, where we work and consult with companies around the world to help them make the most of AWS and serverless. If you're an experienced serverless engineer and you want to join us, then there's a job ad in the description below, and just fill that out and hopefully we'll get to jump on a call and you may be the next member of the Complete Coding team. Well, thank you for watching this video, and I will see you in the next one. These aren't running the real AWS services. They are all there. The next advantage is that I've forgotten it again. Oh.